This short demo is about using the Finch class, and just backs up the lecture that we did in class. So at the top up here, after our comments, talking about what the comments about what this particular project is for, the import statement, and it has to be typed in exactly as shown, and that finally points to the Finch class, and that's a capital F. The rest of this structure is created by the university that put together this Finch class. So this has to be typed out exactly. Also, we're in BlueJ, so what also has to happen in BlueJ, you have to copy the library. It's called finch.jar. You have to copy the library and put it in a very specific location. So to do that, let me minimize this actually. We go in here, Tools, Preferences. Okay, we're in BlueJ. And then here, we go to Libraries. And you notice finch.jar is loaded right here. So this is the folder it has to go in. So if you installed the x86 version of BlueJ, then it goes in /program files x86 /BlueJ /lib for library /user lib for user library. And you just paste this file in this folder. And then when you restart BlueJ, it will automatically load up that particular library. So with that library loaded, we can then use our Finch robot. And when we type this in, it won't cause any errors. Now, if it doesn't recognize it, we'll get an error here because it can't find this library. So then we got our class. I just called this one my Finch. And we got, of course, our main our main method. So first we have to instantiate the Finch object. So it has Finch, my Finch equals new Finch. This shouldn't be new to you except for we're using a different class. In this case, we're using the class called Finch. But this structure should not be new, should be a review. Then below this is where we have a couple loops. We got a while loop that controls when to terminate the program. Inside the while loop, we have a conditional statement which will test if the door is still shut. So this is using a method called isObstacle. So you can see that there's a lot of different methods available for this. We'll take a look at the API in a minute. So this one is beak up, so that if the beak of the Finch is straight up and down, that would be true. And then we want to say while it is not up, stay inside the loop. So as long as that's not up, the loop continues. As soon as that beak goes up, it kicks out of the loop. So while it's in the loop, it goes through the conditional statement. If there is an obstacle, so if there's something in front of the sensors in the front of the Finch, that's considered an obstacle. So that would be true if there's something in front of it. So this particular one tries to move out of the way. So it buzzes, and this is megahertz as far as the tone of the buzz that's built into the Finch. 1,000 milliseconds, so that's a total of a second. Then it stops for a second. That pauses it for a second. And that's so this buzzer doesn't get overridden by another command. So you just pause it to let this thing finish. We have the method called say something, and you type in quotes what you want it to say, and it uses the computer's audio to say what's inside the quotes. And then we set the LED light on the beak of the Finch to, this one is red. It stays red for a second. Then we have the wheel velocity. So set wheel velocities. The negative number goes in reverse, positive number goes forward, and we're doing that for a second as well. So, and then we just down here, we're just you quit the Finch when you're all done, and then we're exiting the system. This is optional. This piece is optional, but you definitely have to quit the Finch. So there's a for loop in here. This is just a little sample for loop. This allows you to, and you can change these values any way you want. We'll just make it buzz and increase the megahertz, and does it for a second, sleeps for a second, so you can hear each of the values or the frequencies of the buzz as it buzzes. So that's again just another for loop. So we're using the while loop because we don't know how long this is going to go through, right? We use a for loop if we know exactly how many times it's going to go through the loop. We use a while loop if we're not sure. In this case, we're not sure, so we use a while loop and wait till the beak is up. And when the beak is up, it turns this thing off because it stays in the loop while it's not up, right? That's what we got the exclamation point where, meaning not. All right, so let's take a look at the API. So the API of this, let me pause for a second. Here's the Finch API, and there's a link to it and a PDF in the assignment as well. So you can look at the PDF, or you can go find the actual API is linked through a website. But anyways, we go down through here, we can see all the methods. Here's all the different methods. We got there's an accelerations, left light sensor, get light sensors. All right, returns 2 integers array containing the current value of both light sensors. So you can see there's lots of different things in here. Acceleration, X and Y acceleration, and Z acceleration. Is beak down, is beak up, is Finch level, is Finch upside down. If the left sensor is left light sensor, is left wing down, is obstacle. So you can see all the different, if it's shaken, it's tapped, temperature sensor in there as well. Don't worry about the play tones. Here's the say something one we're going to take a look at. Here's the set LED, and you can see there's different ways of setting the LED light, lots of different options. So a lot of different overloaded methods there. And set the wheel acceleration, left, right, and then we have left, right, and for a time. And again, we got left and right is negative is reverse. So if I click on this, it takes me down into here, and it gives you this more specifics in this case, and go from negative 255 to positive 255. Okay. Anyway, so that's the end of the Finch demonstration.